chemical equilibrium. Without taking much of your time today, if you are new to my channel, please, you can just try to hit on the subscribe button to subscribe to our channel, and also click on the like button to like our video. Now you see, one of the major difficulties that we always found in chemistry under this chemical equilibrium is how to apply the Lechatchelor's principle, the dynamic equilibrium. Majorly, a static equilibrium is meant for what? A static objects. Altogether, but we are referring to a chemical reaction. Most of chemical reactions are all in dynamic equilibrium. So chemical reactions are in dynamic equilibrium. What do we mean by dynamic equilibrium? That is the major point of this topic today. Now, there are different forms of chemical reaction. We can have what we call a reversible reaction, reversible reaction, and we can also have what we call an irreversible reaction. Now, when we talk about a reversible reaction is a reaction that can go in two different directions. Simply means they are reactions that can move in the forward direction and they can also come back in the reverse direction. That is what we call reversible reaction. We normally make use of this symbol to denote a reversible reaction. Examples of these reversible reactions are found in different applications in industry. Now, let me take the application one by one. Now, the first application of a reversible reaction, for example, in the production of ammonia. Ammonia is being produced from nitrogen gas and hydrogen gas to formulate NH3. I think we can have 2 here to make ammonia. Now, this reaction here is a reversible reaction. Altogether, so this is a reversible reaction. This is showcasing that when nitrogen is reacting with hydrogen to produce ammonia, at the same time, ammonia is being decomposed to form hydrogen. That is the backbone. If ammonia decomposes, it formulates nitrogen and hydrogen. If nitrogen reacts with hydrogen, it formulates ammonia. This is the forward reaction, while this one is the reverse reaction. Altogether. Now, what are the major properties that is required for a chemical substances to be in a chemical equilibrium? What are the major things that you need to take into consideration for a chemical reaction to be in chemical equilibrium? Number one, the reaction must be occurring in a closed system. The reaction must occur in a closed system. Now, that brings us about a system. What is a closed system? A closed system is a system that does not interact anything except it with its surrounding. It is a system that does not interact masses with the surrounding, but it can interact it with the surrounding. Let me bring it to this here. Now, normally a system is meant to interact with the surrounding in two ways. It is either by exchange of heat with surrounding, and it can also exchange mass with the surrounding. What do you mean by mass? Like addition of something to the system. For example, now, if I have water in this place here, water is an example of mass. I can add another water to it. If the system is an open system, I can add water to it. That is exchange of mass. But a system that is a closed system can only exchange heat with the surrounding. The system does not exchange mass with the surrounding. Automatically, it makes that for a system to be in a dynamic equilibrium, as I said earlier on, all reversible reactions are in a dynamic equilibrium. Now, for a system to be in a dynamic equilibrium, it simply shows that the forward reaction must be equal to the backward reaction. What does that mean? What I'm trying to say is that the concentration of the forward reaction must be equal to the concentration of the backward reaction. Then we said the reaction is in a dynamic equilibrium. That is number one. Concentration must be equal. Concentration of the forward reaction must be equal to the concentration of the backward reaction. Then the system is in a dynamic equilibrium. That is number one for that. Number two criteria for a system to be in a dynamic equilibrium is that the system will not be affected by a catalyst. The system cannot affect. That means a catalyst does not affect the system. The only thing that catalyst does to the system is only to slow down the time for the reaction to occur. That means catalyst can only have effect on the rate of the chemical reaction, the rate of the reaction. Catalyst has no effect on the equilibrium of the reaction. Take note of that. That is the third condition that will make a reaction to be in a chemical equilibrium. Altogether, we like that. I'm sure that we are following up with this. Now, that is that for that. You now see, if on that point where questions are being asked, when it's going towards this kind of chemical equilibrium in John, is the aspect of is the aspect of what? Equilibrium constants. Equilibrium constants. Equilibrium constants. Sorry. Now, when we talk about equilibrium constants, actually, if I have a reversible reaction of this kind, A plus B to give rise to C, D plus, C, and D. Now, this is an example of what? Reversible reaction, whereby we have the what? The reactants. This is the reactants, and here give rise to the products of the reaction. Now, when we said equilibrium constants is the ratio of the concentration of the products to the concentration of the reactants. The ratio of the concentration of the product to the concentration of the reactants, that's what we call what? That's what we call equilibrium constants. Now, these equilibrium constants can either be for a solid and a liquid, and we can also have an equilibrium constant for what? Gases. All together like that. Now, if the reaction is a solid or liquid, then the equilibrium constants that we are referring to here, we are referring to the what? The concentration of the reaction. But if the what? The substances that is here, the state of the what? Each substance is a gas, then we refer to what? The pressure. All together. So in this case here now, we can have equilibrium constant as Kc. This is what? Concentration. Equilibrium constant based on what? Concentration. This will be equals to what? For any equilibrium constant, it is the concentration of the products to the what? Concentration of the reactants. Now, it simply shows that this is the concentration of this here. This capital letter are used to denote concentration, while each of these small letters are used to denote the mole of the reaction. So from here, I can have the concentration of C multiplied by the concentration of D. But the problem here is that what? For each concentration, that mole, if you have to write equilibrium constant, that mole will be serving as the power of the reaction. Now, from here now, I'll be having this C as my mole. I'll be having C here. While this small d here will be representing D for the product. All over, that of the reactant will be what? Concentration of A multiplied by concentration of B. And here will be what? A to what? B. Now, this is the concentration, equilibrium constant. Now, if we can only use this Kc if what we are referring to is a solid or liquid. But what we are referring to, if the reaction that we are referring to here are only gaseous. For example, I have nitrogen plus hydrogen, to give ammonia, NH3. Now, this reaction here is an example. We can easily write the what? Equilibrium constant for this reaction. But for this reaction, everything here are gases. We have gas all together. So the equilibrium constant for this is always denoted as what? Kp. Because gases cannot be affected by concentration. Gases can only be affected by what? Pressure. They are not affected by what? Concentration of the what? Reactant. So in this case here, we use the only equilibrium constant as what? Kp instead of what? Kc. And this thing has two effects. Take note, this Kp here is the equilibrium constant for the forward reaction. If the reaction is going forward from the reactant to the product, we can have Kp. But if the reaction is now moving backward, the backward reaction, then we can take that as Kp1 to be equal to inverse of the what? Forward reaction. That means the concentration for the backward reaction is always equal to the inverse of the constant of the what? Equilibrium constant for the forward reaction. That's another thing I want you to take note of. If you are going like this, I'm only going in the forward direction. If I'm going backward, I'm going in the what? Backward direction. That is the function of this arrow here. And its own equilibrium constant is given as what? Kp1, which is equal to 1 over Kp. Take note of this also on our equilibrium constants. All together like that. Now, this is what you note of. Another major important thing of this topic is not the Le-Chatelier's principle, as I said earlier on. When we talk about Le-Chatelier's principle, what do you understand by the word Le-Chatelier's principle? Okay, before I move on to that, I want to explain something. I said I want to use this as an example so that everyone can understand what I'm trying to say. Now, let's write the equilibrium constant for nitrogen as a gas plus what's hydrogen as a gas to give ammonia 2NH3. Before I move on, please take note that what? This is the industrial preparation of nitrogen. Nitrogen is prepared in the industry. Altogether, it is prepared in the industry using the process of what? Alba process. Alba process. Alba process is used in the production of nitrogen, in the production of ammonia in the industry. Why? That of what? H2SO4, if you have to produce tetrasulfate acid, we make use of what? Contact process. It is produced in what? In the industry using what? Contact process. That is that for that. Now, let's take a look at this. Don't forget I said catalyst does not have effect on chemical equilibrium. It can only have effect on the rate of what? A reaction. The rate at which the reaction will do. I think I saw a question in JAM. They said, which of the following is affected by what? The rate, the chemical equilibrium. A catalyst can affect which of the following reaction. I think I said entropy. Entropy, we now have activation energy, and we now have what? Equilibrium states of the reaction. Now, a catalyst can only affect the activation energy. Why? Because the function of a catalyst is to reduce the activation complex altogether. And when the activation complex is reduced, it simply shows that what? The reaction will move in a faster direction than the normal direction that it is going. That is enough for that. Okay, for us to write the equilibrium constant for this, we can easily write our Kp. Please don't forget that I said it is what? Kp. And this Kp indicates that what? The production of ammonia from nitrogen and hydrogen. So from here, I'll be having Kp to be equals to NH3. That is the concentration of this. This is not concentration. What? If you are using this symbol, we are referring to what? The pressure. Are you getting me? The pressure of the gas, and this one here of the what? 2, that is the mole. While here of the what? Pressure of nitrogen gas. The number of mole of nitrogen gas here is 1, which is raised to power 1. And here the pressure of hydrogen gas. The number of mole of hydrogen gas is 3. This is the equilibrium constant, Kp, for what? Ammonia, production of ammonia by what? Alba process. That is that for that. I think that is quite easy. But the major points of question in this, when I know that what? Many students always fail this aspect of question is the use of what? Lekatsky's principle. I said that on that what? A chemical system, a chemical reaction is in what? Chemical equilibrium. Equilibrium in the sense that the forward reaction must be equal to the backward reaction. Simply means, the forward reaction balances the what? Backward reaction altogether. And the equilibrium can only change if there is a changes in the property of the system. What are the properties that they're referring to here? The first property that they're referring to is the pressure. The second property is the concentration. And the third property is now the temperature of the system. Temperature. Altogether, we have the pressure, the concentration, and the what? Temperature. If there is any changes in any of these properties of the system, then the system will leave the equilibrium position. But normally, it will, according to the chart earlier, it said it will surely continue to be in what? In a state of what? Equilibrium. If there is any changes in the what? In any of these properties, then the system will need to shift in such a way so as to what? To counter the changes that have what? Occur. Altogether, it simply means if there is an increase in pressure, there will be a changes in what? Equilibrium position. And if there is a decrease in pressure, there will be a what? A changes in what? Equilibrium position. But this is where JAM always confuse many students. How do we use property of pressure, concentration, temperature? Now, can you see these three properties are factors. They are factors affecting the equilibrium position of a chemical substance, of a chemical reaction, of a reversible reaction. So these are the three factors affecting the equilibrium position: the pressure, the concentration, and the temperature. I'll be starting today with the equilibrium position of what? A chemical reaction. Let's take a look. Reaction. We can have what we call an exothermic reaction. Take note of this. We can have an exothermic reaction and we can have an endothermic reaction. I want to explain, please don't forget, we want to take a look at the factor one by one. And I'll be starting with the what? Temperature factor first. How does temperature reaction is a reaction that involves heat being given out together. Now, what we mean by that. Now, we can easily determine the kind of reaction that this thing is. Either it is exothermic or it is endothermic. How do we determine that? That type of reaction can be determined using the enthalpy of the reaction. Enthalpy, the change in enthalpy. Now, take note. If the change in enthalpy is negative, it simply shows that what the reaction is going to be what exothermic. They are going to give you. If it is going to be an exothermic reaction, they will put in the front of the reversible reaction here. Take a look at it. We will put in the front of the reversible reaction, we are going to put change H to be equal to negative something. But if it is an endothermic reaction, they will put it there that what change H is equal to what positive. But what do they want to determine there? They want to know how does the factor of temperature, how does increase in temperature affected the what equilibrium position? How does the decrease in temperature affected the what equilibrium position? That is what we want to know. I want to get on like that. Now let me now show you something here. If I write something for you like this, I said in an exothermic reaction, we can determine if a reaction is exothermic or endothermic. For exothermic, it simply means change H must be negative. And for an endothermic reaction, it simply means change H must be positive. Another thing I want you to note under these two things is what? In an exothermic reaction, take note, in an exothermic reaction, the heat of the reactants is greater than the heat of the product. Heat of the reactants, let me take like this, heat of reactants is greater than what? Heat of product. That means there is more heat in the reactants than the product. That is when the reaction is exothermic. But when the reaction is endothermic, it simply means the heat of the reactants is less than the heat of the product. What does that mean? Simply means the product has more heat than the what? Reactant. That is quite easy. That is the best method that you can use to understand the temperature factor. How do we do that? Now, they can ask you a question like this. How does the temperature affect? If, take note of this, if, for example now, they said, increase in temperature. Are you getting? If the reaction, sorry, let me take it like this. If the reaction is exothermic, if the reaction is exothermic, altogether, don't forget that exothermic is saying something like this. Let me show you what I'm trying to say. Now, if the reaction is exothermic, it simply shows that there is more heat in the reaction. For example, I just put here as change H to be equals to negative. It simply shows that what the reaction is exothermic. Altogether, now, for it to be exothermic, that means there will be more heat in the reactant than the what? The products. Are you getting something now? There is more heat in the reactant than the what? The product. Simply means the reaction, if it is an exothermic reaction, altogether, increase in temperature will only favor the backward reaction. If it is an exothermic reaction, if the reaction is exothermic, if the reaction is exothermic, it simply means there is more heat in the reactant than the what? The product. So when we increase temperature, it will favor the forward reaction like this. More heat will be going to the what? Forward reaction. But if the reaction, a decrease in temperature will favor the backward reaction. I don't think we are getting what they are trying to say here. If the reaction is exothermic, we know that normally the reactant has more heat than the product. So when we now increase the temperature of the system, when the temperature increases, then it is going to favor the what? The forward reaction. Okay, sorry. Sorry, I think there was a mistake here. Sorry. Let's try to come back to this. I made a mistake here. Now, this is it. Now, if the reaction is exothermic, this is an exothermic reaction. For an exothermic reaction, between the reactants and the products, we know that what? The heat of this one is more than the heat of the what? Product. It simply means when there is an increase, if there is an increase in temperature, then the backward reaction, which is having more heat, will be what? Will be favored. Like the reaction will shift. So that means the equilibrium position will shift to the left hand side when there is an increase in what? Temperature. Why? Because the left hand side is the position of high temperature. Altogether like that. Now, when there is not decrease in temperature, when there is a decrease in temperature, the equilibrium position will shift to the right. To the right. Why? Because a decrease in temperature will only favor the forward reaction if the what? Equilibrium, if the what? Reaction is exothermic. Altogether. Now, if the reaction is endothermic, for an endothermic reaction, in an endothermic reaction, this is what we know. We know that endothermic reaction, the heat of the products is more than the heat of the reactants. So, if you now increase temperature, when there is an increase in temperature, it is going to favor the product side. Why? Because it is the product side that has more heat than the reactant side. So increase in temperature will make the equilibrium position to shift to the right. Why? The right is the position of what? Increased temperature. Altogether. Now, when we now decrease temperature, if there is a decrease in temperature will favor the side with the lowest temperature. Are you getting me? Please take note. How do we know that it is an endothermic? For it to be endothermic, then they will put here as what? Ordinary positive. Positives, it will be a positive number. Like plus 2, 3 something or whatever. It will be positive number. Altogether. So if it's positive number that we are having here, it simply showcases that when we increase the temperature of this, when we increase the temperature of the system, increase in temperature, then it's going to favor where there is more heat, which is the product's side. Altogether, then we will now decrease the temperature of the system. A decrease in temperature of the system will favor the backward reaction where there is low heat. Altogether like that, the equilibrium position will shift to the left. What I'm trying to say is that what? If it is an endothermic reaction, if we increase the temperature, then the equilibrium position will shift to the back. If we increase the temperature, the equilibrium position will shift to point of what? High temperature, which is the product, according to what I wrote here. Now, if you now decrease the temperature, the equilibrium position will shift to the left, where there is what? Low temperature. That is the simplest way to analyze effect of what? Temperature. That is how temperature affected what? The rate of what? Chemical reaction, chemical equilibrium, and how we can change it. How to get out like that. Now, the next thing is that, let's take a look at, you see, the factor of temperature is applicable for either solid or liquid or gas. All of them are affected by what? Temperature. Altogether, then the next thing is now pressure. Factor of pressure. Now, I'm going to be what? Dropping an easy way to understand this pressure factor. Pressure. Now, how does pressure affect chemical equilibrium? It is quite easy. The way pressure affected chemical equilibrium, there are two factors that pressure depends on. Are you getting what I'm saying? Now, before you can use pressure, it depends on what? Two factors. Number one, the equation, the reversible reactions, each of the substance of the reversible reaction must be gases. Each of the substance of the reversible reaction is what? Gases. It simply shows that what? Pressure can only have effect on gases. It does not have any effect on any other substance like solid and liquid. So the first factor that pressure depends on is that what? All the whole reactive substance must be what? Gases only. Gases. All the reactive substance must be gases. Number two is that what? It depends on the molar volume. It depends on the volume. Volume of each gases. Depends on the volume of each what? Gases. So the first thing is that what? Before we can use the factor of pressure, then number one, there must be gases. Everything that is reacting must be gases, or some part of it is gas. Are you getting us now? And the others are maybe liquid or solid. Are you getting me? But it only have effect on gas. Let's take, for instance, altogether, it have only what? Effect on gas. It does not have any effect on any other what? Substances. Altogether like that. That is that for pressure. Now, how does pressure affect chemical equilibrium? It is affected in this way. According to the what? Boyle's law. According to Boyle's law, I'm going to be using two laws to explain it. The first one is the Boyle's law, and the second one is now the Gay-Lussac law. Gay-Lussac law. Now, according to Boyle's law, it said the pressure of a given mass of a gas is inversely proportional to the volume. Simply means the pressure of any gas is inversely proportional to the volume. What does that mean? Simply means pressure when there is an increase in pressure, it will favor a position with low volume. When there is a decrease in pressure, it will favor a position with high volume. Please take note of this. This is the major problem that we have. Now, how does pressure affect it? You know, what this thing is saying is that what? When pressure increases, volume will decrease. When pressure decreases, volume will increase. Now, how do we now apply this? How do we know volume? Now, let me use production of ammonia for instance. Nitrogen gas plus hydrogen gas, how we get to one now? To produce NH3, which is 2, and here is 3. Altogether, according to Gay-Lussac is trying to tell us that what? When gases react, they do so in what? In volume. Are you getting which bear the same what? Which bears a constant ratio with the what? The products. How do we know about this? Now, before these gases can react, these gases that are reacting with each other, according to what Gay-Lussac, if number of mole of gases that is reacting here is 1 mole, mole of gases reacting here is 3 mole, mole of gases reacting here is 2 mole. But Avogadro's law changes that mole to volume. So if I'm having 1 mole, it simply means for nitrogen, I have 1 volume of nitrogen. Number of volume of hydrogen I have is what? 3 volume of hydrogen. While here I have 2 volume of ammonia. That is what we have. So 1 volume of nitrogen, 3 volume of hydrogen, that is the reactants. While the product is 2 volume of ammonia. I want to get on like that. So how do we apply the what? How does pressure affect gases? Don't forget I said it can only affect gas. How does it affect it? Now, we've been able to understand that we can convert the mole of the gas to the volume of the gas. That is number 1. Number 2, the second thing is that what? We can now apply pressure, Boyle's law to find the factor. Altogether, now let's now go. Increase in pressure. How does an increase in pressure affected the what? Production of ammonia in our process? How does increase in pressure affect it? This is what you're going to know. You know, I said now, when there is an increase in pressure altogether favors increase in pressure favors the position with lower volume, according to Boyle's law. That when pressure is increased, then the volume must be what? Low. Altogether, so increased pressure favors the position of what? Lower volume. Altogether, now let's take a look at this. How many volume of the reactant do we have here? This is 1 plus 3, which is 4 volume. Volume of product that we have here is what? 2 volume. Altogether, now the position with the lowest volume is the product. It simply means when the pressure of the gas increases, are you getting me? Increase in pressure will favor the forward reaction. That means the production of ammonia. Why? Because it is the forward reaction that has the lowest volume. So when I increase the pressure, the forward reaction, which is the production of ammonia, will be favored. Altogether, the second thing is that what? What about now? If I now decrease the pressure, decrease in pressure, where will it favor? Decrease in pressure. How is it going to favor? Where is it the forward reaction or the backward reaction? Where is it going to favor? Let's take a look at it. According to Boyle's law, when the pressure is reduced, then the volume must be what? Increase. So where do we have increased volume? There is an increased volume in the reactants because the volume of the reactant is 4, while the volume of the product is what? 2. So when you decrease pressure, then that decrease will favor the backward reaction. They will now ask you a question. Where will the equilibrium position shift? The equilibrium position will shift. When there is a decrease in pressure, the equilibrium position will shift to the left. It is shifting to a position where it is favoring. Altogether, when there is an increase in pressure, don't forget that it favors where there is a low volume. It will favor where there is a low volume. Simply means the equilibrium position will shift to the right. It is going to shift to the right. I saw a question on this. At the end of this video, I'm going to be giving you most of my research on this topic in JAM. The questions have been set for long, and I'll be dropping questions for you. For those of you that want to get my question, there will be a giveaway for the students. Then just drop your answer in the comment box section below. Now let's try to continue our video. Thank you so much. So if you have understood this, you can just drop a comment for me if you really understood what I'm trying to say here. Now, what I'm trying to say here is that how pressure and temperature is affecting the chemical equilibrium. I've been able to explain the temperature and the pressure aspect of it all together. Now, let's now move on to how does concentration affected the equilibrium position. Concentration is the easiest one. Why? Because when you increase concentration of one side, it is going to favor the other side. When you decrease concentration of one side, it will favor that side that you're decreasing the concentration. That one is even the problem. Let me show you something here. Now, how does concentration affect the rate of a chemical reaction? Affect either solid or liquid or gases. All together like that. Now, and then this plus this. Now, how does concentration affect this reaction? Let's try to know. Now, you see, this is one substance of the reactants. This is another substance of the reactants. This is one substance. This is another substance. How does this concentration affect each of this? Now, when there is an increase in concentration of any of these reactants, I get something now. If any of these reactants is increased, it is going to favor the forward reaction. If I increase the concentration of A or I increase the concentration of B, then the forward reaction will be favored. Simply means more C and D will be produced. I want to get on like that. So increasing concentration of any of these will yield more of the products. Altogether, what does that mean? It simply shows that when I increase concentration of any of these reactants, the equilibrium position will shift to the right position. That is one. Now, if I now decrease the concentration, decreasing concentration of any of these reactants will make the equilibrium position to shift to this same position back without going forward. That means if I increase the concentration of any of this, then the equilibrium position will shift to the right to favor the forward reaction. That means more of this will be produced. Altogether, now if I decrease the concentration of A or B, then the equilibrium position will shift to the left. So produce more of that A and B. That is the problem that many people does not even understand. Now, it is only when you increase any of this concentration that will make it to move forward. But when you decrease any of it, it will move backward. The equilibrium position will shift backward back. The reverse is always the case. Now let me show you. Likewise, look up. Likewise is that if I have this product side, I'm talking about the reactant side. That if I increase the concentration of any of these two, it will favor the forward. But if I decrease the concentration, it will favor the backward. That means more of it will be. If I decrease it, that means more of it will be produced. Now, moving on to the product. If I know that the product can only go backward. The product can go backward to the reactant. Now, if I increase the concentration of any of this, increase the concentration of any of the product will favor the backward reaction. That means more of this will produce. But decreasing this concentration will favor the forward reaction back. That means if I decrease any of this concentration of C and D, then more of that C and D will be produced from from this point here. That is the easiest way to understand each of these factors that is affecting chemical equilibrium. I want to get on like that. Now, this is a factor affecting chemical equilibrium. So increase in concentration will make it, depends on where they are giving to you. Either they are giving you reactant or you are giving the product. I'm sure that we've been able to understand this. Now, it is question section. Let's move on to questions that have been set on this in JAM. My research that I make on this topic in JAM. Now let's take a look at the first question that I saw here. I'll be solving the question one after the other. I think I've prepared it to go into different aspects. Okay. Now, my first thing, I have some questions that I've given down for some students to just answer for me, and you drop the comments in the comment box section. Now let's start with this. Now let me start with this. consider hydrogen gas plus iodine, which is gas, to give 2HI when change H is negative. When change H is negative. Now, when change H is negative, the problem is that what I want you to predict, we want to predict where the equilibrium position will shift to. Where is the equilibrium position is going to shift to? How are we going to predict this? You know, they didn't give us that what either increase or decrease. And if you have to tell me where the equilibrium position will shift to, you tell me the condition, what will happen? Is the temperature increasing, or it will cause what? A decrease in temperature that will make the position what? To shift to that position. Now, from here, first of all, this is the production of what? Hydrogen iodide. Now, the reaction here is an exothermic reaction. Change H is equal to negative. Altogether like that. And don't forget that I said for an exothermic reaction, it simply shows that the heat of the reactants is more than the heat of the products. That is for an exothermic reaction. If the reaction is exothermic, heat of reactant is more than the what? Heat of the products. Now, what will happen is that the equilibrium position will shift to the left. It is going to shift to the position of high temperature, which is the reactant. And what will make the equilibrium position to shift to the left is when there is an increase in temperature. Increase in temperature. So when there is an increase in temperature, it will make the equilibrium position towards shift to the left. Altogether, because it's going to favor the position where there is high heat energy, which is the what reactant. But when there is a decrease in temperature, if there is a decrease in temperature, equilibrium position will shift to the right. When there is a decrease in temperature, why? Because it is at the right hand side here that we have low temperature. So there will be a shift of equilibrium position to the right position. That is done for that. And take notes. Take note of something. They always put one question that. They always put this question out. Okay, I think when I say the question, I'm going to ask it. Let's take a look at this here. That's question 1. They said what? Where will the what? Let's try to predict what will happen to this reaction. So the equilibrium position will shift to the position of what? Highest heat energy. That is that for that. Now let's take question 2. Now this is question 2 that is going here. I think we have this question. They said, if we have 3SO2, that is sulfur oxide, plus what? This is a gas plus oxygen, to produce 2SO3, which is sulfur 6 oxide. Now, this is the production of what? Of sulfur 6 oxide. Now, I said in the reaction above, the effect of decrease in pressure. Don't forget I said all these are gases. And gases can only be affected by what? Pressure. Altogether. Now, pressure factor can only affect gases. It doesn't mean that temperature cannot affect it. It can be affected by temperature also. Like the example I just gave below. Example of hydrogen iodide and what? Hydrogen and oxygen, iodine to form hydrogen iodide. So temperature factor can affect it. Pressure factor can also affect it. Now you are given this. They say in the reaction above, the effect of decrease in pressure on the equilibrium position will lead to what? Decrease in pressure. The effect of decrease in pressure on the equilibrium position will lead to what? First of all, the question is, let's check. On the equilibrium position will lead to what? Okay, let me read out the answers and the option that is here. Now, option A, decrease in the amount of oxygen produced. Decrease in the amount of oxygen produced. Option B, decrease in the amount of sulfur oxide produced. Option C, increase in the production of sulfur 6 oxide. Option D, no changes in the concentration of both the reactants and the products. Option E, no effect on the equilibrium constants. Now, that is where many students will fail. Let me further analyze this. If I decrease the pressure, decrease in pressure of this, decrease in pressure of this. Let's first start. How many mole of sulfur oxide we have here? We have 3 mole. Simply means 3 volume. How many mole of oxygen? 1 mole, making us 1 volume. How many mole of this? 2 volume. Total mole of the reactant, which is total volume of the reactant, is what? 4 volume. Total volume of the product is what? 2 volume. Now, if I decrease the pressure, decrease in pressure will favor the position of what? I volume. I get why? Because pressure is inversely proportional to what? Volume. So when the pressure is small, the volume must be what? High. Now, where will we have high volume? We are going to have what? High volume in the reactant. Simply means if I decrease the pressure, then it is going to favor the backward reaction. More of any of this will be produced. More of them will be produced. But if you watch the option A said decrease in the amount of oxygen produced. No. Amount of oxygen produced must be what? Increase if I decrease the pressure. And also, amount of SO2 produced must be increased if I decrease the what? Pressure. That's what you need to know. Simply means option A and option B are wrong. Option C, increase in production of sulfur 6 oxide. Please note, sulfur 6 oxide here can only be what? The production of sulfur 6 oxide can be increased only if the pressure increases. If the pressure increases, automatically it is going to favor where there is low volume. So if the pressure, as when they said increase in pressure, then it is going to favor the forward reaction. That means more of sulfur 6 oxide will be produced. But because they are referring to decrease in pressure, more of this cannot be produced. Rather, more of this will be produced. Simply means option C is also wrong. Option D, no changes in the concentration of both the reactants and the product. Concentration does not affect this. There is no effect of concentration on the production of this. So option D is also wrong. Now, the last option said no effect on the equilibrium constant. Now that is the problem that is there. Pressure does not have effect. Equilibrium constant is different from equilibrium position. It took me some time to understand what is it. Equilibrium constants, they are referring to Kp. Equilibrium position is talking about is it the leftward position or the rightward position. Equilibrium position are the one affected by all these three factors: pressure, concentration, and what? Temperature, not the equilibrium constant. So the option to this is there was no effect on equilibrium, on the what? Equilibrium constant. There is no effect on the equilibrium constant. So if you like decrease the pressure, if you like increase the pressure, the equilibrium constant will remain the same. Why? Because the SO2 into what? Raised to power 3 over what? O2 raised to power. Either you increase the pressure or you decrease the pressure, the equilibrium constant will remain what? This thing does not have any effect on Kp, the equilibrium constant. That is the second question that we're jumping today. Now, this is my third example, and I like this question. Now you see, the question is this. Okay, what is the effect of using vanadium 4 oxide? What is the effect of using vanadium 4 oxide as a catalyst in the reaction represented by the following equation? What is the effect of using vanadium 4 oxide? Don't forget that vanadium 4 oxide is a catalyst. They said the reaction that is represented below, 2SO2 plus O2 to give 2SO3. Now, I have this reaction, and then it said H equals to minus S kilojoule per mole. Now, what is the effect of using vanadium 4 oxide in this reaction? Sorry, as a catalyst in the reaction represented by the what? Equation. Now, let me take a look at this. Option A. Option A said decrease the value of H. Decrease the value of H. H simply means enthalpy. And a catalyst will never decrease the value of the enthalpy. The enthalpy remain the same. Either it is negative or it's what? Positive. Why? Because the enthalpy is talking about the kind of reaction that we have. Either it is exothermic or endothermic. Now, option B. Increase the collision rate of the reaction particle. No. The collision rate of the reaction particle will not be increased. Yes, it is not the collision rate that it what increases. Number option C, shift equilibrium position to the right. Don't forget I said catalyst is not a factor that affects equilibrium position. So it simply means catalyst will never have any effect on the equilibrium position. Option D, reduce the time of attainment of equilibrium. Yes. That statement simply means it. Don't forget I said a catalyst is only to affect the speed of the what reaction. Now, for the reaction to come to equilibrium fast, then we can use a catalyst. That is why in many industrial processes, they make use of catalysts. Now, I get us now. Catalyst is being used just for the reaction to come into dynamic equilibrium at the lowest time instead of what? Increased time. Altogether, so the answer to this is what? It increased the what? Sorry, it reduced the time of attainment of equilibrium. The time of what? Attainment of what? Equilibrium. That is what is going to increase for us. I want to get out of it like that. Okay. Now, I saw this interesting question also. They said using Le Chatelier's principle to deduce the condition that favor high yield of ammonia. High yield of ammonia in the Haber process. We have N2 plus 3H2 2NH3. Now, which factor will be used to deduce the what? Which factor will be used here to deduce the production of more ammonia? I think they gave us here that was change H is equals to minus 46.1 kilojoule per mole. They said using the Chatelier principle to deduce the condition that favor high yield of what? Ammonia in the Haber process. I guess how do we deduce the production of high yield of ammonia in this process here? Normally, if I say I should use pressure, why? Because they are what? We can use pressure and we can use temperature. Now, if you are using pressure, what will make more ammonia to be produced? If you watch here, we have 2 volumes of ammonia. I have how many volumes of ammonia? You have 4 volumes of ammonia. Now, for more ammonia to be produced in this place here, then the only thing I will do is that what? I'm going to increase the pressure. Hello? If I increase the pressure, increased pressure will favor decreased volume, position of decreased volume. And then ammonia has the lowest volume. So increase in pressure will favor more of what? Increase in pressure will favor what? More production of ammonia. That is the only thing that is going to favor. Altogether, so we can use pressure factor. We can use pressure factor, which is what? I increase in pressure. I increase in pressure. Altogether. And we can also use temperature factor. Now, if you are to use temperature factor, how do we use temperature factor? We are going to use it in this way here. Don't forget I said for more of ammonia to be produced, because this reaction is exothermic in nature, it is exothermic in nature. If I increase the temperature, of this, temperature factor will make the equilibrium position to shift to the left position if I increase temperature. But if I decrease the temperature, decrease in temperature will shift the equilibrium position to the right. Simply means more of ammonia will be produced. Why? Because the reaction is exothermic. So the only thing that can increase the production of more of ammonia is to decrease temperature of the system and to increase the pressure. So when the pressure is increased, it will produce more of this, and when we reduce the temperature, it will also produce more of this. That is the only way that we can use to what? Increase the yield of what? Ammonia in what? This. Now, let me just use this. Okay, let's take a look at this. The last question, before I give you my own question myself, that you are going to solve for me. Now, this is my last question I'm going to be explaining to you before I'll be dropping a question for you to what? Explain for me. Now, look at it. They said the synthesis of sulfuric acid by contact process employs the following equilibrium step as one of its stages. Now, this is. Oh, sorry. I think I have this 2SO2 plus O2 to give 2SO3. Yeah. Change H is negative. Now I said the synthesis of sulfuric acid by contact process employs the following equilibrium step as one of its stages. Which of the following conditions promote the backward reaction? When we said backward reaction, this is the backward reaction. That means production of SO2 and O2 is the backward reaction. Which of the following promotes the backward reaction? How do we get this? Take option A. They said increase in pressure, decrease temperature. That is option A. Option B, we have increase in pressure, increase temperature, and the presence of the catalyst. Now, please take note of something, okay? Option C, decrease pressure, decrease concentration of oxygen, and then increase in temperature. Option D, decrease pressure, increase concentration of oxygen, and increase in temperature. Option E, decrease pressure, decrease concentration of oxygen, and decrease temperature. All together. Now, how do we go about this? Now, to favor the backward reaction, what will we do to favor the backward reaction? This backward reaction can be favored. Let me use the whole three properties that I've just explained to you to pick the option that is here. Now, number one, they want to know, they are the one giving us that was increase temperature, increase pressure. Now, here they want to know, is it which of the following condition is going to what favor the production of more of this? How do we get it? Please take note of this. Let me start with pressure. Don't forget that all of them are gases. They are gas. This is a gas. This is a gas, and this is a gas. Now let's start with the what factor of what pressure. So when I say what pressure can affect, temperature can affect, concentration can also what affect. Are you getting what I'm saying now? Now for pressure, let's take a look at the volume of this. They want to find what will make this more of this one to be produced. We want to find what will make more of SO2 and what O2 to be produced. Now let's start with this. Now, how many volumes do we have? We have 2 volumes. We have 1 volume of oxygen. How many volumes do we have? We have 2 volumes. Now, total volume that we have in this place here is 3 volumes. And the total volume here is what? 2. That means high volume here. That means what? Low volume here. According to Boyle's law, pressure is inversely proportional to what? Volume. Then they are asking us that what? They are asking that what will favor this backward reaction, not the forward. What is going to make more production of this? That's what we want. I want to look at how the factor will be. Is it increase or decrease? That's what we want to know. Now, since we have high volume here, 3 volume, we have low volume here, 2 volume. What will you do according to here? Simply means, since there is high volume, there must be a what? A decrease in pressure. That is number 1. Pressure must be what? Decrease. Decrease pressure. Decreased pressure will make more of this to be produced. That is number 1. Number 2, let's take a look at concentration. Concentration. Now, look at something here. I said in concentration, if any of this factor, any of these reactants is increased, then it will favor the forward reaction. If any of them is increased, the forward reaction, more of SO3 will be produced. But we don't need that. We need what is going to produce SO2 and O2, any of them. So the only thing that can produce it is to what? Is to decrease concentration. Decrease concentration. So decrease in concentration, when we decrease concentration, it is going to favor the backward reaction back. Why? Because it will be less. So it will be less, more of this one will produce. More of this one will be broken down to produce this again. So decreased concentration will yield any of this back. Are you getting what I'm saying now? It will yield what? It will make more of this one to be produced. That is it. Then number 3 that we are going to use. We have to look at what? Decrease in what? Pressure, decrease in concentration. Let me take a look at the option. Now, what will make the reaction to shift to the back? Let's take a look at the third factor, which is temperature. And don't forget that I said temperature is even the simplest factor. How do you get it? What kind of reaction is it? Exothermic. If it is exothermic, where is it going to have more heat? More heat to be found in the what? Reactants. Like I said, it is exothermic. So more heat to be found in the what? Reactant. It simply means equilibrium position will shift to the what? Left hand side by what? Increased temperature. So the only thing that can make the equilibrium position to shift to the left hand side, because it is exothermic, is only by increasing the temperature. Assuming it is endothermic, if I increase the temperature, the reaction will shift to what? Where there is more heat, which is the product. But since it is exothermic, if I increase the temperature, the reaction will shift to where there is more heat. Again, this is where there will be what? More heat, the reactants. Exothermic always have more heat at the reactant than the product. So the only factor here is to what? Increase in temperature. Increase in temperature. So increase in temperature will yield more of SO2 plus O2. Increase in temperature what will yield this. So the answer to the question is option C, which is decreased pressure, decreased concentration of oxygen, and then increase temperature. So increase temperature, decrease concentration of oxygen, and then what? Increase in temperature will make the reaction to shift to the backward process. These are the only conditions that can make it to shift to the backward process. That is that for that. Now let's start with my own what? Question. Okay. The first question is this. This is my first question, and I said I'm going to be giving you what? For those that will get my question right, there will be a giveaway after at the end of the video. You are going to drop your contacts, your number for me, so that I'm going to credit each of you one after the other. But the first three to answer the question is what best for me. Now let's take a look at it. Now I have this question that is here. Question 1. They said, when ammonia solution is added to an aqueous solution of copper 2 salts. When ammonia solution is added to an aqueous solution of copper 2 salts, the equilibrium below is established. We have copper 2 ion plus 4 NH3 to give copper nitrate copper ammonia solution, which is a complex salt, 2 plus. Now, they said when ammonia solution is added to an aqueous solution of copper 2 salt, this is a copper 2 salt solution, copper 2 salt, the equilibrium below is established. Which of the following conditions will not affect the position of equilibrium? Which of the following conditions will not affect the position of equilibrium? Option A, we have addition of more ammonia. Option B, removal of some copper 2 ion. Option C, addition of dilute hydrochloric acid. Option D, addition of more copper 2 ion. And option E, increasing the pressure of the system. Option A, we have addition of more ammonia. Option B, we have removal of some copper 2 ion. Option C, we have addition of dilute hydrochloric acid. Option D, we have addition of more copper 2 ion. And then option E, increasing the pressure of the system. Now you can solve now. Let me see what answer at the end of the video was. Checking the answer for each of you. Now, they said, which of them, let me try to read again. They said, which property when ammonia solution is added to an aqueous solution of copper 2 salts, the equilibrium below is established. This is the equilibrium. And I think in this case here is an aqueous, here is an aqueous, and this is an ion. Now they said, which of the following condition will not affect the position of equilibrium? Among the what? Condition that is given to us here. You have just only 5 minutes, just drop the answer. If you are there online, just drop the answer in the comment box section. At the end of the video, I'm going to be checking each answer one after the other. Let's check what you are solving, if you really understand this. Now, what is the answer to this? If it is A, drop it A. If it is B, or C, or D, or E, pick your answer to be any of them. Let's take a look at it. At the end, I'm going to be doing a giveaway to each of the correct answers that we have there. Thank you. Let's take a look at that. Are you ready? Thank you. Now, the answer to the question, now in the time is up, the answer to the question is E. Now, why is it E? The reason is because I said pressure will never have any effect on aqueous except it is what? Gases. That's the question that they're asking. They said, which of the following conditions will not affect? All this one that they are here, either you add ammonia or you remove some of any of them. If you do anything here, you are only doing the concentration. So it is going to affect it. But if you like, increase the pressure. or decrease the pressure, it will not have any effect on it. Now let me give you another solution where pressure will not have effect. Pressure will not have effect when, look at this. I think I have something here. If the volume in the right hand side, I want to check something. Okay, thank you very much. I think I saw something here. Now, in this case here, I have hydrogen ion, which is gas, plus iodine ion to give 2Hi, which is gas. Now, this is another problem. Forget about everything is a gas. I said pressure can affect only gases. If pressure are affecting gases, there will be an exception for this. Pressure will never affect if the volume of the gases in the two sides are equal. No effect. Pressure have no effect on it. If you take the volume here, this is 1 and 1. 1 plus 1 will give rise to 2 volume. And the right hand side is what? 2 volume. So since the volume in the left hand side is equal to the volume in the right hand side, effect of pressure will not take place. That is why in the production of this, we only consider the effect of concentration and temperature. It's only concentration and temperature that can affect this. Pressure will never affect it. Let's take a look at this one, and this one will not take much of our time. They said which property, if you are there, you can also drop an answer to this. Let's check. They said which property of a reversible reaction is affected by a catalyst. Which property of a reversible reaction is affected by a catalyst? You only have just only 3 seconds to answer the question. That is the only thing. The first 3 answers to what we say, that's what I'm going to predicting. Now we have some which property of a reversible reaction is affected by a catalyst. A, we have heat content. B, we have energy of activation. C, we have free energy change. D, we have equilibrium position. Now, what is the answer to the, if it is A or B, just do A, B, or C. Which property of a reversible reaction is affected by a catalyst? Okay, the answer to that is energy of activation, which is B. It is only activation energy that can be affected by catalyst. Now, the rest of them cannot be affected by catalyst. None of them can be affected by catalyst. We have heat content, energy of the activation, free energy change, and equilibrium position. None of them will be affected by catalyst, except the what? Activation complex. Now let's take another question. Just drop the answer to that. It is going to be a calculation. Drop the answer to it in what section. Okay, I think I have this. This one should be the theoretical answer. They said, which of the following equilibria is unaffected by a pressure change? Which of the following equilibria is unaffected by a pressure change? Let's take option A. Option A, I have 2NaCl solid, and then 2Na solid plus Cl2 gas. B, we have H2 gas plus I2 gas, and then we have this and 2Hi gas. Option C, I have 2O3 to give 3O2, all gases. And option D, we have 2NO2 gas and then N2O4 gas. Which of them is not affected by pressure? These are the options. Which of the following are not affected by the pressure? Now, before the count of 1, the answer should be what? The answer should be B. I think I've been able to answer this question before anybody answer it. Now, the question to this is that this is it here. So we have what? The answer is B. Why? Because the number of mole of this is equal to the number of mole of this, which is 2 plus 2. To give us what? This is 2, this is 2, this is equal. Now, there is a problem here. Solid, this is solid, this is solid, this is gas. So far there is one gas. Please take note. This one will be affected by pressure. So far there is single gas there. Just that number of pressure in this to give 2Hi, which is gas also. Now, given that the partial pressure of the following substances at 48, they gave us the partial pressure. Hydrogen is 0.085 atm, and then iodine is 0.48 atm, and then I should be equals to 0.4558 cm. Yeah, they said calculate the equilibrium constant Kp. Equilibrium constant, that is option A. We are going to calculate Kp. Equilibrium constant Kp at 48, and also we are going to calculate the equilibrium constant for the backward reaction. The backward reaction equilibrium constant. Equilibrium constants for backward reaction. What will be the equilibrium constant for the backward reaction? Let's see if we can get that. Let's see. So, if you have your answer, you can drop your answer in the comment box section for me. Just drop the answer to the calculation in the comment box section. I don't know where I might get here, but just try to solve it. And for those of you that don't understand the formula to use, it is highly the same, the formula I've given to you. Just write the what? Kp as the product, which is hi squared, this is the square, and then h times I. Now solve it. That is for the what? I don't know. Just try to solve this out. Now, so the answer to that, just drop it for me in the comment box section. And before we move on, before I call this class a day today, I just want to advise the students that are online to tell you that we'll be having another online section live on YouTube tomorrow. So make sure you prepare yourself, and this same time, 3 o'clock tomorrow, we'll be having a live section on YouTube. But before I go, I'll be having this will be giving you what? Let me drop a question that you're going to answer for me. Drop the question and drop the answer to the question in the comment box section. And the question is, what is the name of this given compound H2S2O7? What is the name of this given compound? Thank you for watching today's video. Please hit on that subscribe button and the like button to like my video, and also share my video with your friends and family. Thanks for today's section. Thanks so much. Fantasía,